Hi, I'm Joe. I'm terrible at technology, as you can tell. This is a bunch of research I did over the past year on CSRF, how it works, how to protect against it. I'm going to go really fast because there's a lot of slides and a lot of information. If you don't know something, just yell and tell me and I'll explain it. I'm going to try to burn through these as quick as possible so I can get some code and demos. We'll see how far we can get. So it's 2018, and I know what you're going to say. Why are we still talking about this? This is a well-understood vulnerability that we have, for the most part, patched in a lot of frameworks, front-end and back-end. What could I possibly have to add to this subject that hasn't already been said? Well, the truth is that people still fuck it up a lot. It's like constantly. Like there's new reports coming in. Hey, it's here. You didn't block it. So the goal in this research was to find a way that we can take a solution that is universalizable for the most part, drop it into an application without having to do a bunch of fixes to the code base itself, and be pretty sure that we're going to have something that can protect the vast majority of cases. So what is CSRF? If you don't know, it's essentially an attack where an attacker forces a victim to make a request on their behalf. So me, the attacker, and you, the victim, I'm forcing your browser to make a request that you wouldn't otherwise do and take some action on your behalf. And that could be something as bad as transferring money from your bank account to mine, changing your social network profile like the Sammy Worm on MySpace. And this is basically what it is, like at the most distilled down concept. How does it work? Really what it comes down to is a flaw in how cookies work. There's an idea called the same origin policy, or SOP, and I'm not going to go super deep into this, but essentially what this does is it blocks one origin from interacting with another in terms of accessing the DOM, making XHRs, things that you typically don't want one origin to do to another and get that data, because there might be sensitive data in there and it would be bad. Cookies don't follow this, and it's a bad thing. When you make a request, whether it's coming from the origin or from a different origin, as long as the host matches it, or the domain in the cookie, it's going to be sent automatically. And the problem with that, as we'll see, is that you can then force users who are logged into one website to make a request from another one that has that impact. So there's a few different types of CSRF that we're going to talk about. And there's three different. The first is resource inclusion. And this is the most common one you'll probably see. Typically, this takes the form of I, the attacker, have a website, and I'm going to put some tag on there that loads a remote resource. And that could be something like an image or an audio or video object, like Flash, something that loads in a remote resource. And if you have a resource, for instance, like your bank account, that allows you to pass the parameters as get parameters, you can put this into the source address. When you load that page, you're going to request that. And the image may not show up, it'll be broken because data doesn't come back for it, but that request is still getting made, and so the damage is already done. This attack is limited to GET requests, so if you do implement your application correctly and you use POST requests or some other unsafe verb to make the request, then you should be able to stop this type of attack. And so like I said, a basic example of this is going to be something like that. So I would send you to a page, and there's an image tag like this on it, and it passes its get parameters, and you then send me all your money. The second type is form-based, and this is a little more useful, especially when you start getting into the cases of proper use of safe and unsafe verbs, where get and head are safe and everything else is essentially unsafe. I, the attacker, will take a form that I generate. It has a bunch of hidden fields in it with all the data filled out, and a little bit of JavaScript that forces you to submit the form. I put this on a page. I send you to that page, either through like an email, through phishing. Say, hey, check out this really awesome deal you can get, or this cat meme. And you go there, you load the page, and the JavaScript forces you to submit that form, and it will do the same thing that the resource did. This is good if you have to go different origins, like you don't have access to the site that you're trying to attack. And it's useful for phishing, like I said. There's cool things you can do, like hiding this. And so like you can put this into iframes or do tricks with pop-ups. And it's really hard to detect because, as you'll see here, this form just gets submitted. The victim ends up on the action page, so it might look like nothing happened. You'll load the page, and then all of a sudden you're there. You don't really know what's going on, and if you're not looking for it specifically, it's not really clear. The last one is XHR, and this is pretty rare, typically because it requires XSS to use, unless you have like a really horrible CORS configuration and allow cross-origin requests from like arbitrary URLs. Basically, you're just using a typical XHR to make the request. The same origin policy does apply to XHR, and so you're not going to have that same ease of use. And one important thing to say here is that if you do have XSS on the website, no matter what you do in any of the techniques we're going to look into in a little bit, it's game over. You know, XSS defeats everything. Like once you have sufficient access to inject arbitrary code into the page, you can bypass anything that's anything that you're going to do. Basic example, just regular XHR. So there's a few current solutions that people will typically use. Like I said before, using safe and unsafe verbs correctly. So when you're requesting data, you use a safe verb. When you're making a state change or you're modifying something, you will use an unsafe verb. And the reason you do that is because you can't force an unsafe verb through resource inclusion or something other than being able to physically run code or arbitrary HTML. The second is verifying the origin. When you do something like using correct verbs, verifying the origin technically is enough. And what you're doing here is you're verifying that the origin that the request is coming from matches the URL for where it is. So my origin is my bank, and I'm requesting a resource or a URL that is on the bank, and not like my origin is attacker site and I'm going to the bank. Verifying that can be done by looking at like the refer or the origin headers and then checking that against the host header. And then the last, and this is the most common you'll see in most frameworks, is a synchronizer or a crypto token. These are pretty much ubiquitous at this point. Any modern framework is going to use this. If it's not, you should probably look at new frameworks and definitely use these techniques. Well, a bit of a disclaimer, the code I'm going to show here is simplified, and there is more to it. The full code is online in a Git repo that it's going to be at the end of this, so you can go there for the actual code that is used and a more complete example. And there's a full write-up that I did that's much longer than this, and will give you a lot more information and background knowledge. So why are we doing this? Because we want to solve CSRF like once and for all and be done with it and be able to fix these applications that don't have support for it. Places where this makes sense, like say you're a web hosting provider or you have a bunch of websites that you have acquired or that you're now managing, and you don't really control the frameworks they're on. They're on old versions of libraries, and you can't really upgrade them. Either people don't know how they work, you can't go and fix them. This is a really good situation for that, because this can be done at any level in the stack where you can either modify the code or sit like at a load balancer or a WAF. And this can fit into any of those levels. So it's good for that kind of situation. The only requirements for this is basically you have a relatively modern browser. I'll have a support matrix for all the code that I'm going to show. But basically, it works. I've gotten this to work in pretty much everything like IE8 and up. So like if it's like a reasonably modern browser, you should be fine. We're going to support all the cases, so resource inclusion, XHR, and form-based. And we're not going to introduce a lot of additional latency or CPU requirements, memory. We need something that's very efficient and something that's not going to be noticeable to your application and your ops team. So like I said, correct safe verb use. This is something that you can't automatically fix. This is something that you have to build from the ground up. The code that I'm going to show will work around this in some cases. It's kind of a pain in the ass to support this, but it's something that you can do if that's a use case you need. Utilize good frameworks. I mean, like, this is one of those things, just do it from the beginning. Basically, any modern framework will come with a router, and it will take care of that for you. It'll let you set up your endpoints, and it'll just kind of make sense. So just do it. The verifying the refer and the origin, like I've already said, this is technically sufficient without synchronizer tokens if you use safe and unsafe verbs correctly. Almost no one does, at least in older apps. It's becoming more common now, but people still screw up all the time. There's a great blog post there about implementing this. You should definitely read that. And this is good if you're supporting cores. And I don't know how common that is, but if that is one of your use cases, it's something you should look into. It's really useful for it. You basically just will look at the origin header, if it's there, or fall back to the refer and compare that with the host. They should be equal. You can't always trust this because the origin header isn't always required. And the refer may or may not be there, dependent on the user agent that's sending it. It's kind of up to the browser and the extensions that are running it. So we typically will use this as a first pass, and if it's not there, we'll fail open and fall back to the tokens just because it's a little safer. So tokens. They come in two different types. You get synchronizer and you get crypto. Basically, no one uses crypto. They're not very good. They're inefficient, especially if you don't have like crypto assisted hardware that can do the operations. Basically, what this is designed to do is tie an individual user to an action and synchronize their browser with the server so that you can verify that the user did indeed make that request on their own behalf and not from an external website that forced them to. And there's a lot of cool things you can do this. We'll look at composition really quickly. Basically what this is you have some nonce that's just a random value that you generate. You've got a user ID, and this is anything that is user identifiable. An expiration time. This is something that is typically handled by the session, but if you want to go a different route, you can give it like a specific time, like an hour, 2 hours, a day, and then some authenticity. On the modern frameworks, you'll typically see these as implemented just as a random value, because if they're stored in the session, you get authenticity because the user can't modify their session, as long as you're not using something dumb like client-side session storage with authentication on it. It happens. I mean, people are dumb. User IDs, this can be anything, like a user ID from the database, some unique identifier. You can use a session string. It doesn't really matter. The one thing to note, though, is that as soon as any one of these is compromised, you lose basically complete faith in it. If authenticity especially is compromised, you're no longer able to trust it, and you can just forge tokens all day long, and it doesn't matter. The difference between crypto and synchronizer is that crypto is usually an encrypted value that you pass to the user agent and then decrypt it on the server. Like I said, it's slow. Don't use it. Synchronizer tokens typically have something that the server side stores or is able to validate, and then the client just sends it up, and it's a quick operation. So now for the actual implementation, and this is split. You have the server and the client code, and these are, the server handles generation and validation of tokens, and the client handles sending the tokens with the request, and this is what it uses to validate the request. So you can use each of these independently. So like if you already have on your server side some code that does generation and validation, you can use the client side technique if your application, like your front end application, doesn't support this. And you have a, for instance, like you're not using a front end framework that does this for you. And if you do have one that does this for you on the front end, but your back end doesn't support this and you can't easily add it into that, you can use the token generation and validation at your load balancer or anywhere else that sits in front of the application or like in the middleware stack or something that you can add in without having to go modify like the logic of the code. The generation is pretty simple. Basically, you're passing in a user identifier and some key. This key is being used for an HMAC, which is an authenticated hash. So you'll hash the data with this key and use that to verify that you're not changing it, because the only way to get that same value of that hash back is with that key. So as long as that key is safe, it holds up. And you pass in an expiration time, and you do all this. You'll see that I'm using hyphens as the delimiter. Don't use colons. They're not cookie version 1 supported. And if you have an old browser, it's going to not be happy. Validation is also really simple. You split it up and you recreate the part that you hashed. And then, like I said, you use that hashing algorithm with the key and you generate a new hash. And then you compare the hashes together. And as long as those hashes are the same, you know that the token coming up is an expected token. Make sure you use a constant time hash comparison, because otherwise you can introduce side channels and you can identify what that was and basically pick up the valid hash. Sending the tokens back. This is like the real JavaScript meat. This is like the thing that took the longest time for me to kind of get working, and working around all the different browsers. So to handle forms, basically the way that this works is we're injecting some JavaScript onto the page, and it's going to wire up some event listeners. So I ended up using the click event listener rather than form submit, because the form won't bubble up once it gets past it. It'll stop at the form element, at least in most of the browsers. So if you use the click event handler on document, you can defer it up to there and then kind of walk down and see if it was clicked on something that was inside of a form that originated from a button. And you have to do all this manually because you don't get things like jQuery or any of the nice utility libraries that everyone kind of got used to using. So this is the code for it. Like I said, it is simplified, but basically the way that this works is you look at the target of the event when it fires, and you check to see if it's either like an A tag, an input tag, or a button. And these are the ones that you're looking for. Now, if you built something like with a div and you're turning that into a button, you can add any other element, or if you want to go more direct, you can use CSS selectors in here. This was done just because it seemed to catch the vast majority of everything being used. So basically, you're walking up the tree, identifying the element that was clicked, looking for one of those. And so we're looking for it, we find it. And then we go from there, and we need to find out if we're in a form. So we're trying to find out if we're a button that's on the page, or if it's not in a form and it's just a click, or in the case of a link like that. But this basically lets us figure out if we're in a form. And if we're in a form, it means that we then have to submit the token with it. Once we're there, we're going to look to see if a hidden element has already been added or is in the form. And this is where our token is going to get stored. So we do that. We're going to check our cookie, because that's where the token gets added. It gets added to the response on the way down. And we're going to take that value and we're going to drop it into the form. And then once this finishes, this will fire right before the form is submitted. So in between your click and the form being submitted, you are inserting the token into the form in real time. So we're always going to have the most recent version of the token from the cookie. So if you're using Ajax and you're making a request, your cookie is always getting updated. So you're always going to have a new token and always a fresh token. And so this is going to always update it for you every time you do it, even if you don't leave the page. For XHR, this is a little more complicated. And this is where like the real monkey patching gets into. And like this is one of those things that everyone tells you, like, don't ever do this. But like prototypal inheritance is kind of cool, even though it's awful. So basically what we're doing is we're hooking the XHR object, and we're overriding open send so that we can intercept any call that's done, whether you're in some like deeply nested framework being used or you're like some other library. Everything is eventually going to come down to the XHR object. So as long as we can intercept this, we'll get every framework that's on top of it. The only exception to this is like if you're using like Flash or like Java applets, but like those are kind of dead at this point, so it's probably safe to say that you don't have to worry about it unless you're like in a government website, and then I'm sorry. So this code specifically, sorry. So the form code will go back to like IE like 5.5 because like everything. Oh, if you swap out the query selector and go back to something like more old school, but this is limited to IE8. Technically, like 7 should be supported, but Microsoft broke the prototypal inheritance in IE7 for certain objects, and so you can't override prototypes on XHR, which is unfortunate. You might be able to implement this like with a custom ActiveX control, but like I didn't do it, and I don't really want to. So this is basically what the code does. So you keep a copy of the original send because it's a reference, and then you just like rewrite the send method, and in there you're adding in an additional header to the request before it gets sent up. So the X requested with is used because it will force, what was it? There was something that it forces the client to do, but it also lets the server side know that you're running with XHR as a request and not like a full page refresh. I think it makes the origin header go into place or perform like a pre-flight check for cores or something. Then, like I said before, you grab the token out of the cookie and you write this into the header, and then you just call the original like send method, and then everything works as it especially would. And now you have this token that's added into the header that the server can validate. So the code here for the isRequest header set, I had to do this specifically because if you do it twice, like if you set a header that's already been set, it will like append the value you do, like with a comma delimiting it. And so the code on the server side gets really unhappy when that happens. So you might have to write a little bit of like code to handle that. It's all in the example on GitHub. So like the full code is there, you can see it. You also probably want to like not do this with cross origin. There's a whole bunch of other gotchas there that you have to deal with. So core sucks, but like you can kind of like deal with it. There's a handful of toggles you might want to add. One of them is the secure cookie flag. This makes it so that cookies are only sent up from the client to the server. If it's over HTTPS, you don't want to leak your tokens, because anyone that's on the network watching it can steal it. That's bad. Protecting safe verbs. So like if you are unfortunately in a position where you are using like safe verbs incorrectly and you're using them for state changing, you can do some magic where you say, hey, I actually do want you to protect the safe verbs. The only caveat to that is you have to have a carve out of like specific URLs you can go to. Otherwise, every GET request, like your initial request, will fail to send down a token and basically like, oh, this is CSRF. Like you can't do that. So you got to carve out some like URLs that are like safe to go to like load the initial token. And then cross-origin and permitted hosts. If you do want core support, you can allow specific hosts as being like valid origins. This is the support matrix. It's all from Can I Use for the various features on here. And I tested all of these in browser stack, something like that, yeah. It might work on older ones. I couldn't find older browsers in some of these cases. But this is what it does. And so it pretty much supports like everything like that you might want to use. In the case of like older IEs or IEs that are using like the legacy like I'm this IE but I want to behave as this IE mode, there's some like logic you can add in to identify which version it is and figure out if it actually supports the functionality or not. I had to go through all that pain and it was like really shitty, but once you figure it out, you basically have to look at the user agent and figure out like what version it really is and what it's pretending to be. And then you use the one that it really is, because even though it's pretending to be something, it still gives you the functionality that says it doesn't. So for the future, we can all like, ignore all this in the future. So there's this really cool thing called same-site cookies, and this is an extension to the cookie spec. And basically, it allows you to add in the same origin policy to cookies. No browsers support it yet, and it's still a draft. So like, it kind of sucks, but it's cool. It basically makes.
Show me this then.
It's coming. It's gonna be here soon. Yeah. So it comes in two flavors, strict and lax. Lax will enforce it for safe verbs. Strict will enforce it for safe verbs, and lax will not. You basically never want to use strict because it will have that same problem of like, if I'm like logged in and I go to a page from another page, like it will just be like, nah, this is CSRF. Like you can't do that because it won't send your cookies up. So it won't think you're logged in. So you always want to use lax pretty much. Just trust me on that. You're gonna have a bad time. If you really want to use strict, you can do some like crazy redirect magic where like you come to the site originally and then you redirect them back to the same page they're on. And because they're on the site, the origin is the site, and it will then send the cookie up that time. Yeah. So like it sucks, but like it's like the same thing. Here's the spec right there. You can go read it if you want. It's not very long and it's pretty easy. Browser support. You get Chrome. I think, yeah, it landed in Firefox pretty recently, or is going to in like the next version, I think. And you get it like in Android Chrome, but like nothing else. Microsoft might do it. I don't know like if they're going to, but in conclusion, like CSRF is a solved problem. Just like you can use all this and solve it for most of your cases. And we should stop like allowing these kinds of attacks to happen. Like it's something that is just like, we know how to fix this. Like just do it. Same site is the future, and we should all start using it. It's really cool because any browser that doesn't support it won't complain. It just won't do anything. So like you can start adding it in right now. Anyone who has a browser that uses it like will be totally fine. But if they don't, like it'll just ignore it as like something that's like, oh, this is garbage. So that's cool. So in conclusion, that GitHub link is the demos, and if we have time, I can walk through some of them really quick. But it also is all the code that runs like all of this stuff. The Medium post is a blog post that outlines like all the material in here and more. If you want to read it, it's really, really long, and it also has a link to the video that you can watch from DEF CON last year. And that's okay, but the blog post is better. But for people that have short attention spans, just do the video. That's my email, Twitter, and we're hiring if you want to come hack on like V8 and like Node like runtime and other like really terrible fun things.
All right, give it up. Okay. I might regret this, but I think we're going to take one question because we're kind of over time, but
Sorry.
We have to ask one question.
What sexy font? What sexy font was that code slide using?
Which one? This one?
Yeah, oh, you skipped it.
Oh, that one?
There you go.
That's Hermit.
What is it?
Hermit?
Hermit.
Open source, free font, It's awesome.
Okay.
Yeah.
All right, let's Why do all of this? Why? In particular, why did you do all of this, right? Like monkey patching, we say like, oh, that's bad,
My
but
company paid me to. We sell a security product that offers this to our customers.
Got it. Customers wanted it.
Yeah.
awesome. So that's it. That's the first JS.la of the year. And I hope to see everybody over at Drinks.js, over at Barkowski.